My name is Sina Rabbany and I'm the Junior Distinguished Professor of Engineering and Director of Bioengineering Program at Hofstra. I've been at Hofstra since fall 1990, where I came here to start the bioengineering program. My interest in bioengineering started during high school. I tend to be very good in mathematics and physical sciences. At the same time, I found the biological systems intriguing. Recently, we have started a cell and tissue engineering laboratory at the School of Engineering and Applied Sciences at Hofstra. And within this lab, we are interested in the area of tissue engineering. There is a disparity between supply and demand for people who are waiting for organ transplantations and availability of organs. So the natural option here would be that how can we be able to come up with the strategies whereby we can make organs in the body either repair themselves or be able to come up with the ability to tissue engineer new organs potentially for replacement. The interest of our laboratory is vascular biology. Every organ in the body needs to have a supply of blood to it. As a result of that, it needs to be enriched with blood vessels. In the laboratory at Hofstra, we are specifically working on this area of vascularized tissue engineering, whereby we are trying to find out how does nature build blood vessels so we can exploit this design and engineer potentially vascularized constructs that in future can be used for treatment of patients with end-stage diseases. One of the wonderful things about bioengineering program at Hofstra is that is primarily an undergraduate program. So all our resources are there to train undergraduate students. This gives students opportunities to actually be involved in research at an early stage during their career. At other institutions, usually such opportunities are reserved for graduate students or postdoctoral fellows. Bioengineering, like most other STEM fields, is a very challenging field to pursue. Students are required to have good background in mathematics and sciences in high school. When students decide in pursuing a career or decide a choice of study in college, they normally are either interested in sciences or engineering or not. To become a bioengineer, like any other engineering field, you need to have a very strong background in mathematics and physical sciences. A number of our students, despite the fact that they're majoring in bioengineering, they're planning to use that as a stepping stone to getting accepted to medical school. And the program is currently structured such that you can fulfill the pre-med requirement while pursuing your major study goal, which is bioengineering. In addition to that, graduating as an engineer gives you the advantage that you have obtained a potential terminal degree, and availability of jobs is much higher in engineering in comparison to basic sciences. As basic scientists and engineers, we are engaged in doing work at the basic level, with the hope that this work in future will become translational and would actually benefit the public, in this case by developing potentially tissue engineering construct which could save lives. Research could be both viewed as very exciting and yet challenging. I constantly remind my students the reason they call it research is because you have to attempt to repeat what you do several times. We are hoping that by engaging undergraduates in this research, we are able to emphasize to them how contagious excitement could be, and by making them immerse themselves in the work, they can experience the life of a basic scientist or engineer in future.